Example 2.3.3. An AC voltage has a maximum amplitude of 625 volts and is applied to the terminals of a 50 ohm resistor in series with a 50 ohm inductor. Find the average real and reactive power in the circuit. The givens in this problem statement are that we've got a peak value of our voltage or a max value of the voltage of 625 volts. We have a resistance in our circuit of 50 ohms, and we've got a inductor that has 50 ohms of inductive reactance. We're asked to find the P and the Q in the circuit. So the solution starts by knowing that the formula for P is equal to Vmax Imax over 2 cosine of phi, and that Q is equal to Vmax Imax over 2 sine of phi. A lot of times these are rewritten as V RMS I RMS cosine of phi and V RMS I RMS sine of phi. That comes from the fact that V RMS is equal to V peak over root 2, I peak over root 2 is equal to I RMS. So you see if we multiply those two terms together, we get V peak, I peak over square root of 2 times square root of 2, which is just 2. So these terms are just equivalent, different ways of writing the same thing. So what are these Vmax and Imax quantities? Or alternatively, the RMS quantities? Well, we were given problem information to just directly determine VRMS. That's going to be 625 over root 2. Dividing the peak by root 2 converts it to RMS, and we're going to use that as our reference so it gets at angle 0. So that's 441.94 at angle 0 degrees volts. It's RMS voltage. We can use Ohm's law in its impedance form to determine the current. We know that I is going to be equal to V over total circuit impedance in this case. So that's 441.94 at angle 0 degrees divided by the series combination of that inductive reactance and resistance 50 plus J50. That gives us a current of 6.254 at an angle of negative 45 degree amps right there. So we've got our RMS voltage, we've got our RMS current. That's an RMS value because I used RMS in the numerator of this fraction here. Power is going to therefore be equal to 441.94. I'm going to take that times 6.25, doing a little rounding there. That's going to be, whoops, excuse me. It's going to be times the cosine of 0 minus negative 45. And that gives me a value of 1,953.12 watts. Q is going to be 441.94. That's the RMS voltage magnitude times 6.25, which is the RMS current magnitude times the sine of 0 minus negative 45. So that is going to give me 1953.12 var right there. A lot of time we'll write the solution as the combination, combination of P plus JQ. So, total power is going to be P plus JQ. So the total power in the circuit is 1953.12 plus J, 1953.12.